All right. So one of the things you need to know or recall is that you have, you're going to be taking next week, I think it's next week, a 25 question test. You have 1 hour to complete the test. There's a number of things that you need to know to successfully accomplish or pass this test. And that is, you need to know some basic, well, I say basic, but you need to know how to do unit conversions, meaning metric to metric. You need to know how to go from metric to household and household to metric. And you need to know how to do some fluid intake calculations, some drug label, medication labels, and you need to know how to decipher whether or not you are doing, whether or not you're doing, or what you're administering to the patient, whether that's tablets, capsules, milliliters, etc. So we're going to talk about all those in the context of going through this. And like I said, some of this I'm going to go through a little bit quickly, but if there's something that you need me to show, show my work for, or show where I got my answer for, just stop me and say, wait, can you work that through? And if you don't want to say it out loud because you are afraid that, you don't want to ask that question, just send it as a direct message to me where only I see it. I won't say who said it. And then we'll talk about it. So a lot of these initial questions are just going to be basic unit conversion type questions. So and your first few questions here, you can see there's 7 questions listed here. You should be able to get through these pretty quickly. And what I mean by that is, like, if whether you use dimensional analysis or you just do like what I'm going to do here, I'm just going to move my decimal point over 1, 2, 3. So my answer for this question is 1.5 grams. Didn't really have to do too much math. I just had to write in my answer. Same thing here. I know that going from micrograms to milligrams, my number is going to get smaller, 2, 3. So this is 0.25. Now for going from pounds to kilograms, I personally need my calculator. If you can do that in your head, great. But I'm just going to take the patient's weight in pounds divided by 2.2. That's going to give me 75 kilograms. I'm going to take the patient's weight, 117 in pounds, divided by 2.2. Now here I get 53.18181818. So in the chat, what should I put as my final answer if I get an answer of 53.181818? Just type it into the chat, what you think it should be. Good. Perfect. And that is exactly what it's supposed to be, because you're supposed to round to the nearest 10th. And that's something else that you need to know and something we've talked about. All right. Now, pints to milliliters. Now, I always have to sit there and go back and think about what this is. So like, I know that 1 cup is 240 milliliters. And I know that 1 pint is 2 cups, which is 480 milliliters. And if I'm saying something wrong, please stop me so I don't say that incorrectly. Okay, let me just fix my. Except that looked bad. All right, 480 milliliters. So since I'm going from pints to milliliters, I know 1 pint is 480 milliliters. I'm just going to do 1.5 times 480. And then that will give me my milliliters of 720. Ounces to milliliters. This one I do happen to know off the top of my head. 1 ounce is 30 milliliters. So 4 times 30 is 120 milliliters. And then a cup, we already said 1 cup is 240. So half of that would just be 120. Okay. Clearly 120 was the number I had in my head as I was doing some of these. Are there any of those 1 through 7 that you need to see again, need to see how I got to that answer, or you feel pretty good? If you feel pretty good, just you can do a thumbs up if that's an easy thing to point on or put on your thing, or just don't say anything is fine. I'll move on to the next thing. Yeah, for 7, I took half of 240. So 240 divided by 2, which is 120. You're welcome.
Okay, Doctor, I also have a question about that too. So, like, what if it says like 3/4 of a cup?
Good. Thank you for bringing that up. Okay, so if it says 3/4 cup, this is actually where it's helpful to do dimensional analysis, and I'll show you. I'll show you that way, just because it can be helpful. So if it's 3/4 cup, okay, and I know that 1 cup is 240 milliliters. What I'm going to do is I'm going to multiply out across the top, so 3 times 240, which gives me 720, and then I'm going to divide by 4, which would give me 180 milliliters. So the rule is with, or not the rule, well, yeah, I guess it is a rule with fractions. If it's 3/4, you're going to multiply by the numerator, divide by the denominator. Is the simplest way of doing that. Or if you do like to use dimensional analysis, which I recommend because it helps to keep you, and you might be like, well, what's your unit down here? There is no unit down here. It's just, that's how you would write 3/4 cup, is just 3/4.
Okay, thank you. And that would work for anything that would be like fraction, a fraction of a cup or something like that. If you understand what I'm saying.
Yes. Yeah, that's how you would do that. The only thing that might be different is if like you are or what might make a challenge, and you shouldn't see a question like this, but let's say we were going from let me just see here. I'm trying to think of how I want to say this. Yeah, let's just say I'm doing like let's say it was written out as 3/4 milliliters, and I want to know how many cups that is. I would still set that up basically the same way. I would say 3/4. So remember, it's 3/4, so the milliliter stays on top, times, and then here I'm going to go from milliliters to cup. 1 cup, 240 milliliters. So you can see this number is going to be really, really small. I'm going to multiply across the top. I get 3. Then I'm going to, so 3 divided by 4. Then I'm going to divide again by 240. Now, you're not going to see a question like this. I'm just giving you this as a scenario, because then you're going to answer 0.003125. That most likely you're going to be converting from the household units to the metric system, because the metric system is what you're going to be utilizing. But if you did get a question like that, this is how you would set that up. But you're not going to see that. So don't stress too much about it if that made you like get queasy. The way I wrote up this other one, the 3/4 cup, is going to be more likely what you'll see. The type of question, at least.
Okay, thank you. Yeah, because those ones like kind of like throw me off when it has like a half, like when it's a fraction, that throws me off. Thank you.
Mm-hmm. You're welcome. Just remember, it's all the fraction tells you is what you're multiplying across on the top number, what you're dividing by in the bottom number, and then do your conversion. So let's do some of the fluid intake questions. So with these, we're converting everything that is liquid into milliliters. So the first thing, and this is one that like I don't think you're going to see. I think you'd see like a half glass orange juice. I don't think you're going to see a quarter or even 3/4. But if you do, you would do this the same way. So what I'm going to do is I'm actually going to take 1/4. Okay. And I'm going to multiply it. That's supposed to be a 4. So 1/4 times 8 ounces. I'm just going to put it over 1. I just want to show you how I'm kind of chopping this up. And then I'm going to convert ounces to milliliters. So 1 ounce is 30 milliliters. Another way of doing this is if you just sit there and you think about, okay, 1/4 of a glass. So what's 1/4 of 8? Well, 8, a fourth of 8 would be 2, because 2 plus, there'd be 2 and 2 is 4. Another 2 is 6. Another 2 is 8. So it's broken up into fourths. Or I could take 8 divided by 4, gives me 2. Or if I set up a long dimensional analysis here. Really, the only thing that's different than how you would traditionally do any of these other types of problems is just accounting for the 1/4. And like I said, you're going to multiply by across the top, divide by what's on the bottom. So for this one, 8 times 30 is 240 divided by 4. And then you're going to get 60 milliliters. Seems like just like a drip. It's like a shot of orange juice. They didn't really get much in there. Then for the coffee, I'm just going to multiply by 30 mil because it's 30 milliliters per ounce. So I'm going to get 180 milliliters. Reuben sandwich is not liquid, so we don't calculate that. Even if it tells you it's a 6-ounce Reuben sandwich, it's a solid. We're not calculating solids. We're looking for the liquids. 2.5 ounces. Again, I'm just going to multiply by the 30 milliliters. So 2.5 times 30 gives you 75 mil. And then a 1/2 pint of chocolate. I think we did the 1/2 pint up there, but remember 1/2 pint is the same thing as what? 1 cup. So this is just 240 milliliters. Then you would just add those all up. So I would take my 60 plus 180 plus 75 plus 240. And I'd get 555 milliliters as my total amount. I'm going to do the same thing for this question. We have 6 ounces, right? So I'm just going to multiply by the 30 ml. You should know I'm simplifying this. You know, I know that 1 ounce is 30 milliliters. I'm assuming that you know that 1 ounce is 30 milliliters, which is why I'm just simplifying this process. Okay, times 30 gives me 60 ml. Hot tea, 8 ounces. So that's another 240 ml. And then what about this? 2/3 cup. Okay, so we remember now this is where it gets a little bit challenging. But I'm going to do the same thing I showed you before. I'm going to take 2/3 times what's a cup? We know that a cup is 8 ounces. And then I'm just going to convert the ounces to milliliters. 1 ounce, 30 milliliters. And then I'm going to do exactly what I said to do before. I'm going to say 2 times 8 times 30, which gives me 480 milliliters. Then I'm going to divide by 3. And so that brings it all the way down to 160 ml. The challenge with when you're dealing with fractions also is like, obviously your calculator is not going to be very fraction friendly, especially because you'll probably most likely be using a basic 10 key calculator. And so you could do 2 divided by 3, multiply it by everything. That will work. But sometimes you'll get like a decimal answer if you're accounting for rounding, and I imagine you don't want to deal with that. Go ahead. I see your hand up.
Yes, for number 8, I just had one quick question. I know you finished doing it. In the parentheses, it said, assume a glass holds 8 ounces. So that is similar to what they will give us, or will we need to know that it's 8 ounces?
They would need to tell you, because a glass could be like, I'm sure if you think about in your house, you probably have 12-ounce glasses and 16-ounce glasses and 4-ounce glasses. We have a bunch of different glasses. So they would need to tell you that a glass is holding 8 ounces.
Okay, thank you.
You're welcome. All right, so for this one, then we would just add it all. And that's the same, like the 2/3 cup. I used the 8 ounce, but it was the same thing, right? 8 ounces is 1 cup. So anyways, that was just actually I actually read that as 2/3 glass, but I would have used the same thing based off of the previous problem. So all I'm going to do now is just add up So I'm going to take the 160 plus the 240 plus 60 again plus 180. And that's going to give me a total intake of 640 milliliters. All right, now we can get into some of the medications here. So there's no label for this particular question. This question is actually considered an oral-based medication because it tells you. And then, you know, oral-based medications come in two varieties. It's either something you're swallowing as in a capsule or a tablet, or it's a liquid that you're swallowing. If it's a liquid that you're swallowing, you're going to be calculating milliliters. So the way we would know whether or not we have a liquid or a solid that we're swallowing is you're going to look for things like solution. So an oral solution tells you it's liquid. The other thing is you'll see milliliters associated with the available. So for this question, the lactulose order is 45 grams by mouth 3 times a day. And then the question down below, you can see it says, how much medication will the patient receive in 1 dose? So you need to know that because this is an oral solution and it's a solution, which tells you it's a liquid, you know that you're looking for milliliters. Okay. Very rarely are you looking for something like a teaspoon or a tablespoon or something like that, or an ounce or a cup. If they are looking for that, they most likely are going to ask that, but you need the default is going to be milliliters. So to solve this, there's 2 ways to do that. I can do the long way, in which I'll start off with the dimensional analysis way. Okay. Long but accurate. Okay. So what we're trying to do is we're trying to cancel out grams and then be left with milliliters. And that's what we're going to use is what our label tells us, 10 grams, 15 milliliters. I'm going to take 45 times 15, gets 675, divide by 10. And then my answer is going to be 67.5 milliliters. If I'm doing ordered over available, I'm going to take my 45 over 10. And then this is where most nursing students make this mistake is they forget when they do ordered over have, there's another part to that equation. It's times quantity. So your quantity here is the 15 ml. So you need to make sure you account for that. So those cancel. And then you're left with the same answer, 67.5. One of my Allegheny 110 students asked me, should we divide first, then multiply, or multiply first and divide? And I told him it doesn't matter. Just as long as you're multiplying, dividing the right numbers, it won't matter. But if you want something to kind of focus on, it's probably best to multiply across the top, then divide by the bottom, instead of trying to do each individual step in between. But that's just my preference. You can do however you want to do it. Okay, 67.
I have a question really quickly.
Go ahead.
So on the test, so you're saying that you were telling us how to determine what the medication is going to be in like milliliters or milligrams or something by looking at certain words. So on the test, they're not going to give us like how it is on ATI where it says how many milliliters per dose. It's going to have, we're going to have to figure that out ourselves on the test, is what you're saying?
Correct.
Okay.
Yeah. Yep. And then and just so you know, that's how I've been treating the reviews for you guys this whole semester so far. So if you go back through and review the reviews that I've done, you'll see that a lot of the questions I use as examples, it doesn't tell you what you're looking for. It just tells you to calculate how much to receive per dose. But your answers are going to be either tablets, capsules, or milliliters. That's what it's going to come down to. So you can't give someone milligrams of something. You are ordered milligrams, but you're going to give that you're going to deliver it to them either as a tablet, a capsule, or in a milliliter form. So that hopefully helps to simplify it a little bit as far as what you should be looking for.
It does. Thank you.
You're welcome. All right. So here's an example now with a label listed. Okay. So the order is Xanax 0.75 milligrams by mouth twice a day. Your question says how much medication will the patient receive in one dose? So we need to look at the label and see how is this administered. Okay, because it doesn't tell us anything, but there we go, right? Tablets. So what's your answer going to be? Your answer is going to be in tablets. So I'm just going to abbreviate that tab. Okay. So you can do this a number of ways. You can do the math on this, or you can just look at, you can sit there and go, okay, well, 0.25 milligram is in for per tablet. So they would need 3 tablets. You did that right. If you're doing this, and I'll just do it the ordered over halfway, 0.75 milligrams is your order. Your available is the 0.25 milligrams. And then your quantity is 1 tablet. If you see this 100 tablets, just know that that's how many tablets are in the entire bottle. Okay. That's not how many, that's not 100 tablets does not equal 0.25 milligrams. 0.25 milligrams per tablet. Okay. So your answer would be 3 tablets. Here's another question. It says Zofran 10 milligrams by mouth 3 times a day. And then it's giving you the available. So there's no label to look at. It says 100 milliliter bottle, and it's labeled 4 milligrams per teaspoon. And then it tells you how many milliliters will the patient receive in one dose. So this actually tells you what to look for. So sometimes it will, sometimes it won't. And I think the reason it is because it tells you teaspoons here, but they want to know what it is in milliliters. Okay. Now, one of the things that you should know already is that 1 teaspoon is 5 ml. So another way to write this this unit here would be to say 4 milligrams per 5 ml, which is helpful to know because then you can that's what you actually want to use when solving this particular type of question. So you're going to take your order, 10 milligrams, over your available 4 milligrams, and then your quantity 5 milliliters. Ten times 5 is 50, divided by 4 is 12.5 milliliters. Now, one of the reasons, again, that I'm showing you this too is like, notice that this looks like a fraction, right? 10/4. Okay. And that's what I'm trying to get across is that multiply across the top, divide by the bottom. If this happened to say 1/2, whatever. And then the only thing I did as a prep step was I converted teaspoons to milliliters. Okay. Just nothing wrong with that. That's actually a really good way to do that. And then you might be saying, well, what about the 100 milliliters? That just tells you how much the whole thing is. We don't need to worry about the whole thing. We just need to know how much are we going to, or how much do we need to get from that whole thing. So I don't know about you. Well, I mean, I don't drink soda, but you know, I usually if there was soda available, like a 2-liter bottle of soda, I'm not thinking, oh, I'm going to drink that whole thing. You're probably going to get a glass from it. Okay. All right, here's a label question. The question, I'm just kind of bouncing around a little bit, but if you look at, it says how much medication will the patient receive in one dose? So we got to figure out, well, what are we administering? So I'm actually going to work this question backwards. So first of all, you can see Benadryl. And if you know anything about Benadryl, it comes in tablets. It also comes in a liquid form. So I need to look and see, how is this done? So this is actually an injection. Okay. And then it even says, it actually doesn't say how. It just tells you to shade a syringe. So the syringe might also be an indication that it's an injectable, but it tells you it's an injection on the label. I don't know about you, but I've never seen anyone get injected with tablets or capsules. So how do they get injections? Milliliters. The only caveat to that is if they're receiving insulin, insulin is usually received in units, right? So the syringe will have units listed on it, and then you would draw up 2 units, 4 units, whatever you're supposed to be administering, or whatever they're supposed to be administering, and as opposed to milliliters. But if it's not insulin, we're looking for milliliters for the most part. So insulin and heparin are the only 2 that are typically going to be administered in units, but even heparin gets converted to milliliters. I think insulin is usually the one that's kind of the odd one out. All right, so how would we solve this? Well, I'm going to take my order over my available times my quantity. 65 divided by 50. And I'm going to get an answer of 1.3 milliliters. And then, and I always forget if you guys are doing a Blackboard or paper test, but if it is, if it's Blackboard, then you may not need to do this next step, which is marking the syringe. But if it's paper, you probably will. And all I'm going to do is go onto my syringe. And first of all, I'm going to confirm that these are all 0.1. So this is 1. This would be 1.1, 1.2, 1.3, 1.4, 1.5. So my answer is 1.3. So 1, 2, 3. So I'm going to mark at 1.3 and then shade it in at the 1.3. And then you'll do better than I'm doing with my pencil or my digital pencil here. All right, here's another label question. This is heparin. It says, again, this is another syringe question. It tells us we have 7,000 units. And then it says subcutaneously. Subcutaneously, even if you knew nothing else, you know that's an injection. Injections are milliliters. The only time it's not going to be an injection is if it's insulin. And then I'll show you the one question where that is going to be applied. Okay, so milliliters is what we're looking for. We're looking at our label. Our label also says injection on it. And then we have to look for the strength, and the strength is 10,000 units per milliliter. Okay, so I'm going to take my order, the 7,000 units, over my available, the 10,000 units, times my quantity. And then what I'm going to get is an answer of 0.7 milliliters. Then I'm going to go to my syringe and I'm going to mark it. So 0.5, 0.6, 0.7. Again, if you're doing this as a Blackboard test, you may not be doing this shading in part. At Allegheny campus, they have them drop like a point where they want to mark the syringe. So that is a possibility that you'll have something like that. But as far as, but I don't know because I haven't seen your test. All right. You're also going to get questions on doing a sliding scale. Now, sliding scale, we're not really doing any kind of math here. It's just, can you read the data and then know how to implement the information given? So you'll see, it'll show you insulin. Notice that insulin, you can calculate to the milliliter if you needed to, but this one's not asking you that. This one's just saying, if a client's blood sugar at noon was 315, how much insulin would you administer? And then you're just going to look at the table. and you're going to say, okay, well, where does 315 fall? Well, 315 fits in this range here between 301 and 350. And so you're going to administer 8 units. And that's how you answer. Good. Yep. So this is not a math question. This is just an interpretation question. So if you get less than 70 or set between 70 and 200, then, or less than 70, you're calling the doctor. More than 400, calling the doctor. If they said his or her blood sugar was 150, then nothing. You would just leave it, let it be. So 8 units. So how much insulin should be administered? Notice it doesn't say anything, but you don't need to convert that to milliliters. Just leave it at 8 units. I know that maybe you could go through and do, but if you did that, if I do 8 divided by 100, and then you're going to write 0.08 milliliters, I don't think that's what they want you to do. Plus, I think you guys have all been trained or at least exposed to how to do an insulin injection, and you're using syringes that have insulin listed on there. So I think you know that it's measured in units. And in fact, the other trick here is if they give you a mark the syringe type thing, it'll say it right there, right? It'll have units listed there. That's what that's supposed to say. And then you're just going to mark it the 8 and then shade it in. All right, now for this question, it's another insulin question. And then all we're doing with this insulin question is adding the 2 insulin together. So you should know that regular insulin always gets drawn up first, followed by whatever is not regular insulin. And I think the thing I've been told is like clear before cloudy, or I always think of regular insulin first when you're mixing insulin, and you're just adding those 2 together. So you just take 18 plus 14, which is, I believe, 32. So the total dose would just be 32 units. Scroll down, mark the syringe if it asks you to do so. So 32. You can tell I have a surgeon's hand here. All right, so 32 units. So I think the insulin questions, the sliding scale, calculating insulin, I think that's going to be pretty straightforward. Like I said, there's no math other than just adding them together. There might be follow-up questions like which would you draw at first, but I feel like you would be told what to do, or you would be asked that more in like a clinical type setting as opposed to the math test. All right. Here's another question with a label. It says Synthroid 0.25 milligrams daily. So it doesn't really tell us what Synthroid is in the order, how it's being administered. So we need to know how it's available. We're going to see that when we look at the label tells us a couple of times that it's tablets. It also gives us the strength, and the strength is boxed in here. And you'll see 2 numbers there. You'll see 50 micrograms, mcg, and you'll see 0.05 milligrams. What you need to know is those are equivalent units, so they equal the same. So what I'm going to do is I'm going to use, if I have milligrams in my order, that's what I'm going to use, and I'm going to ignore that. I'm just going to use the 0.05 milligrams for as far as my available is concerned. So knowing that 0.25 milligrams, this time I'm going to do dimensional analysis. I have available the 0.05 milligrams per tablet. I'm just going to write tab. So I'm going to take 0.25 divided by 0.05. And so I'm going to give this patient for 1 dose 5 tablets.
I have a quick question.
Go ahead.
So I know that's the answer, but doesn't that sound kind of excessive giving somebody 5 tablets of just one medication?
Yeah. So what I always say is this is the you're in the CCAC math bubble, and we can disperse from reality just for a few minutes, but I agree with you 100%.
Okay.
Some of that is just what if I created the question, and I can't remember if I got this from somewhere or if I created it, that the numbers were I may have just messed with the numbers, and maybe a better number would have been like 0.15 milligrams, and I just went up to 0.25. So but you're absolutely 100% correct. It does seem excessive. But then again, maybe this person's thyroid isn't working very well and they just need to give it a jolt. I'm just kidding. That's not what this would be. That would not be the answer.
Doctor, I have a question
Yeah.
regarding the dosage and calculation exam. It didn't say, but will there be like drops and like IV medication questions on it?
There shouldn't be. It's
Because
gonna
my
follow.
teacher said that there was going to be questions on the test about it.
It should be following the blueprint, and the blueprint does not have anything dealing with drops or flow rates this semester. Second semester, yes, but not your first semester test. The first semester test is going to be your oral based medications, your injections, your conversions, your fluid intake, and then some of the reconstitution, which technically is just another version of a oral based medication. So there should not be any flow rate questions. If you're being told that, I need to know that, because I've obviously been telling everybody that that's not the case.
I mean,
I
that's
don't think
what I
it's going to
also
be on
read.
there.
Yeah, I agree because I checked the blueprint, but she was like pretty sure that there was going to be those types of questions on there.
There
I
shouldn't.
asked Miss Petro when was it we had class on Tuesday, and she said it wasn't gonna be on there. Because I remember our last ticket to enter for a clinical, we had to do the drips. I asked her about it and she said no. So I don't think they're gonna be on there.
Well, I hope not.
Yeah. So I've been doing this for over 10 years, and there's never been flow rates on the 110 test. So I don't think that they would have changed that and not told me. So I would just go off of what your instructor told you, because they're and then they're going to follow the blueprint. That's why they made it. So but you will get flow rates for second semester. So you can look forward to that. Yeah, you're welcome. Good question, by the way. And I know that sometimes you'll hear something, or if another student says they heard something from somebody, always remember that look for the source material, and then you can always double check with your instructor before you take any kind of test. They'll confirm all that stuff for you. But yeah, flow rates are not here, because I haven't covered that, and I do not intend to cover that today at all, because you don't need to know it yet. All right. Prozac is the order. Notice it says very big. It's Prozac liquid. So without knowing anything else, we know that we are going to be calculating for milliliters. Okay. So when it says how much medication will the patient receive in one dose, you know that you're solving for milliliters. So I'm going to look at my label, and I'm going to look for my strength. 20 milligrams per 5 ml. So my order, 65 milligrams. My available, 20 milligrams. My quantity is 5 ml. Do not forget about that quantity. 65 times 5 gives me 325 divided by 20. And I'm going to get 16.25. So what would I put as an answer if I have 16.25? Give me 1 second before I answer your question. Answer my question. Good. Perfect. Round to the nearest tenth, 16.3 mil. Okay, go ahead with your question.
Yeah, so I was going to ask about like the reconstitution medications, will those be on the exam, and how would we go about doing those ones? Would it be like the same process as like reading the label like we're doing now?
Right. So we're almost that's coming. There's actually 2 examples on this that we're going to come up to. And then so you'll see, and I'll show you how to navigate and even know that you're dealing with a reconstitution. So it's coming up. Go ahead, Aranya.
Yeah, so my question is, when do you know when to round? Because we've been doing all these questions and we haven't rounded. So why are we rounding in this question?
So I've always been rounding if we need to. So the rule is if it's a number greater than 1, you're going to round to the 10th. If you need to. You may not always need to. If it's a number less than 1, you're going to round to the 100th place. What I mean by that is if you get 1.35, you're going to round that to 1.4. If you get an answer that is 0.357, you're going to round that to 0.36. But if the question ends as 0.35, you don't need to round it. If it ends at 1.4, you don't need to round it. You just leave it as it is. But they want you to be, you need to know that you're going to round to the nearest 10th when you need to. And we did that in the, when we converted pounds to kilograms, we rounded to the nearest 10th there. But most of these questions, you're probably not going to have to worry about rounding. There might be 1 or 2 that will ask.
Okay, that's what it was. I didn't notice. Okay, but for this particular one, we needed to because.
Correct.
Okay. Thank you.
You're welcome. Yeah, it's a good question. All right. Here's another. So if you see the word suspension in the question, before you do anything, well, first of all, it says suspension and then nasogastric tube. You're not going to shove pills down a nasogastric tube, right? Please don't. I don't want to hear about you guys on the news that they try to do this. Okay. Just know that if it's suspension, nasogastric tube, milliliters. Okay. The other thing that'll help with that is when we look at our order, 125 milligrams per 5 ml. Okay. Or not our order, when we look at our label. So, and then it also says it's an oral suspension. So we know it's liquid. Okay. So liquid, think milliliters. And even the question here asks how many milliliters should the person receive. I'm doing it this way because it may not always ask you to calculate the milliliters or tablets or capsules. I just figured I'd make sure that you know that. They might be a little bit more lenient on the 110 test, but I think going forward, you're going to have a lot of questions that just says, how much should the patient receive in 1 dose? And then you're going to need to know how to find whether or not you're calculating milliliters or tablets or capsules, which I think you're starting to see that it's not too difficult to find that. It's just a matter of looking at the labels. Oh, and as a side note, something I recommend to all my 110 students, go on and do a Google search for drug labels, and then just look at the different labels and see what they look like. Just get yourself familiar with them. And like I said, if you do an image search, choose your favorite browser or your favorite search engine and look at the different images associated with drug labels, just so you have an idea of what they look like. All right. So my order is 175. My available is 125. Don't forget your quantity, 5 milliliters. So I'm going to take 175 times 5 divided by 125. And I'm going to get an answer of 7. So with an answer of 7, I don't need to round it. I don't need to do anything. Don't write 7.0. Leave it at 7. All right. This question always throws everyone that are first seeing it, because this is the first time you're going to see something that has what's called milli equivalents listed there. it's just another, it's the same thing you would look at if it was ordered milligrams or micrograms or grams. It's just the unit in which the medication is available. So milliequivalents is just a unit. So we are going to look at the label though, and we're going to see that, first of all, I don't know about you, but this kind of looks like, those coffee creamers that they give you, like, when you go places and it's like, to go, it looks like a coffee creamer, but you can see it's even sugar-free. You can see that the solution listed there is 20 milliequivalents per 15 ml. So because it's listed there and we know that it's an oral solution, we know we're looking for and calculating milliliters. Okay. So if it doesn't say anything else, at least now you know where we got that from. So milliliters. So the next thing is I need to calculate this. My guess is yes, that milliequivalents will always be milliliters. I haven't seen milliequivalents used anywhere else other than potassium chloride. So that would be my guess. But again, always look at the label just to be on the safe side. You're welcome. So 75 milligrams is the order, or milliequivalents is the order. Available is 20 milliequivalents. And then your quantity is 15 mil. So I'm going to take 75 times 15. And then I'm going to divide by 20. And then I'm going to get 56.25 ml. I just want to double check that I wrote all my stuff right. 75 times 15. Oh, yeah, that's right. Divided by 20. All right. So what am I going to put as my final answer? Good.
I have a question about that.
ahead.
So I got 56.3, but will it be considered wrong if we just write like 56.3, or do they want us to write it all out like 56.30? You know what I mean?
Right. So you do not. So another thing you need to know is you do not include leading or lagging zeros, meaning do not write things like this. Don't write that, because that could be falsely interpreted as 700, even though you wrote that decimal in there nice and dark. So you would write that as 7. So do not write 56.30. Stop it right at the 10th place. All right. So penicillin, you're welcome. Penicillin, 250,000 units. It's available 1 million units per 10 ml. And then how much medication patient receive in one dose. Doesn't really tell us like anything. We don't really have a label to look at, but what we do have is milliliters listed. So that tells us that we're looking for milliliters. If this were tablets, it would have said 1 million units per tablet. Okay. That's just how that would be. So my order, 250,000 units. My available is 1 million units. And my quantity is the 10 ml. So I'm going to take 250,000 times 10 divided by 1 million. And I'm going to get, with all those zeros, 2.5 ml. Now I don't need to do any rounding. It ended at 2.5 ml. I'm not going to round that up to 3 because I do want it to the nearest 10th, and we're there. So just leave it alone.
I have a question about like the rounding. I know rounding is like stressed heavily as far as dosage calculation goes. Why is it stressed so heavily though? Because when you're administering the medication, like if you get like 56.25, would that still like be the same though as 56.3?
So first of all, the short answer is they want you to do the rounding as part of evaluating that you can do it. So that's part of the math test, is just can you handle the rounding based off of the criteria and the rules that they've given you and like I said, round to the nearest 10th for numbers greater than 1, round to the nearest 100th for numbers less than 1. In reality, and remember, we're in the CCAC math bubble here, which is why this is the rules that we're following. But in reality, like that 56.3 milliliters, you're probably going to give them 60 milliliters. That's probably what the order will turn out to be, and it'll be a little bit more accurate. So you got to remember, some of these are, well, let me just give you a for instance. If you've ever had to take like an oral based medication, like an antibiotic, it's usually a common one. As a kid, if you took like the liquid stuff, and as an adult you take the tablets, you probably notice that no matter who you are, you're probably going to get the same order and get the same administration depending on the medication that you were ordered, because they're following protocols. So if you're an adult, you're going to get 10 of this for a period of this many days, or you're going to get. So what I'm saying is, a lot of this math is just to make sure that you can do the math and do the calculations, figure that out, as opposed to the reality of what you're going to be doing in a clinical setting. So I hope I cleared that out by making it more muddy. Yeah, so don't, so the rounding stuff absolutely is just something that you need to focus on. Like I always tell nursing students, especially as you go on through the different semesters, you know, the only time that you need to be careful about rounding is when you're dealing with pediatrics. And pediatrics, it seems the rule is you do not round. You want to make sure you're getting every significant figure, but all that's also going to be dependent on the medication, the metabolism of the pediatric patient, because remember, pediatric means 0 to 17, so that it can always be dependent. And then when we think of adults, we don't even account for the most part, their metabolism, unless we're talking about certain special cases like insulin or heparin or something like that. So anyways, long answer for, it's just something that you need to know to do for the math test. All right. Another one. So if you ever see, first of all, if it tells you the syringe and it's injectable, you know that you're looking for milliliters. It tells you how many milliliters to administer. But if you didn't know that, if you see that it's intramuscular is it's IM, SC, or IV, you know that it's going to be delivered in milliliters. Okay. So I'm going to just do the same. I'm going to look for my available, no label picture, but it tells me 75 milligrams per ml. 45 milligrams is my order. So I'm going to take 45 over 75 times my quantity. 45 divided by 75 gives me 0.6 mil. Again, you would not write 0.60. I know this is a number less than 1, but you still just leave it alone. It's only important for rounding, or if you got an answer of like 0.63 or something like that, then you would leave it at 0.63. But if it's 0.6 or if it's 1, you just, whatever that solid number is, you just leave that as your answer. Then you just look for 0.6 on the thing, which is going to be right here on the syringe, not the thing, and then shade it in. All right, now we're going to get into almost there. I think the last two are going to be the reconstitution questions. All right, so intramuscular, what am I going to be calculating for if it's intramuscular? You got it. ml. Okay. So the next thing is, okay, well, now I need to figure out what I'm calculating for. So on this is so clindamycin is a antibiotic. And you can see that it's available, and there's two numbers written here. There's 600 milligrams for 4 ml, and then right underneath it, it's 150 milligrams per ml. If you take 600 divided by 4, it equals 150. So all they did was reduce it to the per milliliter, and that's the number I would utilize if I were you. The other thing is you'll see that it's in milligrams, the available, but the order's in grams. So we need to convert grams to milligrams. So this becomes 450 milligrams. So in your blueprint, when it says like two-step, do two-step oral-based medications, this is an example of a two-step oral-based medication. I'm going to take my order over my available times my quantity. 450 divided by 150 gives me 3 ml. And that's your answer. And then you would just shade the dose on the 3. And it looks like I already left that on there accidentally, but we just fill this all in. If they ask you to shade it in, do a better job than that, please. All right, I do believe the last 2 questions are what are called the reconstitution questions. All right, so a couple things to look for when we're dealing with a reconstitution. I mistakenly said they're oral-based meds. They are, but they also can be injectables. It just depends on what we're talking about. So what a reconstitution is it's a powdered medication that you need to add water to it to make it active or be able to utilize it. So it's stored as a powder. It gets mixed usually in the pharmacy, but you might work in a clinical setting where you're going to be the one doing the mixing and stuff. And so that's what a reconstitution question is. Go ahead with your question.
Yeah, sorry about that.
That's okay.
For 23, I just wanted to ask you real quick, why did you use the 150 versus a 600 over 4?
Because the 600 over 4 and the 150 are the same. They're the same number. It's just that if you take 600 and divide it by 4, it's 150. So it's just a reduced number. So you could have used either one and
Yeah.
you would have came out with the same answer.
Okay, so on the test, just get the smaller one and instead of the bigger one.
Right. And it's just a preference. So if
Okay.
you wanted to use the 600 over 4, you would have gotten the same answer I got.
Okay, thank you.
You're welcome. And what I said about that is that the 150 milligrams per milliliter, it's just the reduced, it's the same strength. It's just a reduced, like they reduced the fraction is what they did.
Thank you.
You're welcome. Good question. All right. So for this question, it tells us that we have an order of 325 milligrams intramuscular. Remember, if it's intramuscular, milliliters. Before I do anything, I know that I'm going to be calculating milliliters. Okay. So if we're looking for milliliters, most of the medications that we've had with milliliters have given us something like milligrams per milliliter, right? They've given that in the strength of the medication. Your clue that you're dealing with a reconstitution is that it'll say something like 1 gram and doesn't say anything per milliliter. So that's your clue that we're dealing with a reconstitution question. So what do I do with that? How do I solve that question? Or what do I do next? Basically is what I was trying to get at. Because what you're looking. Go ahead.
I'm sorry, I was just going to say, would you convert the 1 gram to milligram?
I would not. So
Okay.
So first of all, what I'm looking for in a reconstitution is I need to find this information on the label. Okay. So what I was getting at, and by circling the 1 gram, that's just telling you that you're dealing with a reconstitution question, which means we have to go into, and it might be hard to see, but we have to go into the side label. So I'm going to read some of this just in case you can't see what I can see. But it says for the intramuscular use, which is what we're doing, it says to add 2.5 milliliters sterile water. So again, that's something that would be done in the pharmacy, or in certain clinical situations, you might have to be doing that. Now, Kefsol is an antibiotic. So that might be something that if you're working like in a nursing facility or nursing home or something like that. All right. So it tells us what to add. That's fine. Then it says it provides an approximate volume of 3 milliliters. Again, that's good to know. But then in parentheses, it says very small that it's 330 milligrams per milliliter. On a reconstitution question, that's what you're looking for. And what I would highly recommend that you do is, again, with the drug label searches, just do a Google search or whatever. Yeah, we'll just stick with Google search for reconstitution labels, reconstitution medication labels, and then look at the different labels and see how it's measured and how it's done, because all of them look a lot like this. And I'll show you in the second example here in a moment. That is what we're looking for. We're looking for that 330 milligrams per milliliter. That is our available. So I don't do anything with the 1 gram. The 1 gram is somewhat of a distractor. I need to look in the directions and find out what it's going to be after I add the 2.5 milliliter stir of water. So I don't need to worry about these numbers, the 2.5 or the 3, because I already know what my concentration is, 330 milligrams per milliliter. So I'm going to take my order over my available and then multiply by my milliliters. So 325 divided by 330. Gives me 0.98. Now when you get a number like that, and especially when we look at the syringe, you'll notice that we can't really calculate 0.98. Well, 0.98 is obviously super duper close to 1 milliliter is what I would put for this answer. I know that I've been telling you and trying to condition you to do the 0.98 milliliters, but that's close enough to 1. And I don't think that it's close enough to just leave it at 0.9. The other thing is, remember, I created the number without looking at the syringe. And I think that also is playing a part in this, just so you know. It might just be a badly written question as far as the number I chose, but doing the math part, we're still going to get the practice in it. So if I'm answering this question, it's close enough to 1. It's closer to 1 than it is to 0.9. So that's how I'm going to answer this question, is say 1 milliliter. What I should have done is I should have chose a number like 300 or 400, as opposed to being so close to the 330. Go ahead.
For the purposes of the test, if we left it at 0.98, that would have been fine.
My guess is that, first of all, I don't think you're going to have a question like this that's
Okay.
poorly written. But if they're asking you to do a syringe, I would say put it as your answer is 1.
Okay.
You might want to, if you're writing on a paper test, you might want to put the 0.98 to be exactly specific. But if it's asking you to mark a syringe, you can't put 0.98 on this syringe. You can either do 0.9 or 1, and you're literally 200ths from a 1. And so it's 1.
Okay.
Good question.
Okay, I also have a question. So, for the reconstitution ones, we're never going to have like 2 separate numbers in there. It's always going to be like the milligrams per milliliters in the reconstitution label. It's never going to be 2 different numbers.
Well, I would just
like, I don't know. You understand what I'm saying?
like it said in, are you saying like how they had it listed as 2 different numbers here?
Right. Like it's not going to say that like in a reconstitution.
I don't think so. It could, but I don't remember seeing that. So the trick with the reconstitution is just finding the strength. And so, but I haven't seen examples where it gave you like more than just the 1 strength.
Okay, thank you.
Yeah, you're welcome. All right. All right, the last question here is another reconstitution question. And I know that just because obviously I put this together. And I knew that there was 2 in here. So again, intramuscular, before I do anything, I know I'm dealing with milliliters. the label even says before reconstitution. So it tells you it's reconstitution. Okay. So what this is telling you is that once I add liquid to this, once I add sterile water to this, it becomes active and it starts to, I'm assuming it starts to break down, which means it needs to be utilized soon, which is the difference between this type of medication versus any other type of medication. Okay. Or other types of medications. Some of them need to be kept cold. Some of them need to be kept powdered until they're ready to be utilized. And some of them are very shelf stable. So again, we know we're looking for milliliters, but my label clearly says 500 milligrams. That again is your clue that you're dealing with a reconstitution, because it may not every label is going to say before reconstitution, blah, blah, blah. All right. When we look at this, remember, we're going to look at the side label here, and we're going to look for our information. So I'm going to just see if you can find it. If you find it, just type it into the chat. Like, what is the strength or the strength that we're going to use for this ANSEF medication?
It's 225 mgs per milliliters. But I have a question about that. So
Yeah, go
you
ahead.
know how you have to put, it says their administration at 2.0 mLs of sterile water for injection. Would we have to add that at all to our ending answer?
No, because that's just telling you, remember, it's powder, right? So we're adding liquid to powder. So think like if you've ever made lemonade or iced tea and it's the mix and it's powder, right? So you're adding water to the powder and making a solution out of it. So the 2 milliliters, that's just telling you or the pharmacy what to do to get to the concentration. The question being asked is, how much am I going to administer after it's mixed? So the 2 milliliters just tells you what to add. It is not a factor in your calculation.
All right, thank you.
You're welcome. Yeah, and neither is the 2.2 milliliters. All that tells you is what the liquid, or how much you added. When you added it to the powder, the total volume came out to 2.2 milliliters, which makes sense because it was powder. Then we added liquid, and now we got liquid and powder mixed. We have a solution. But what I care about is that 225 milligrams per milliliter. So I'm going to take my order. I would say, again, look at the labels, because not every reconstitution may be in parentheses, but that is what you're looking for, at least in these two examples that I've given you. So good. I think some of you are ahead of me. 250 milligrams, 225 milligrams per ml. Oh, and then on the OneDrive folder that I've shared with you guys, you should have that link that was shared. It should be on Black. I'm assuming it's on your Blackboard. There's a folder there called Reconstitution Labels, and you can click on there. And I grabbed a few from the web, and you can see what they look like, the different types of reconstitution labels. And that should give you an idea. So 250 divided by 225. Yeah, it gives you 1.111111. We're just going to go ahead and round that to 1.1. 1.1, and then I would just mark that on the syringe. 1.1. So the trick with these reconstitution questions, guys, is just knowing where to find that information. And I hope now after today, you know where to find that information. So that's basically what the test looks like. Kind of, I don't know. I can't sit there and tell you with any kind of confidence it's exactly, or I know it's not exactly what you're gonna see because I came up with these questions, but it should give you a feel for how the questions on your test will be arranged, and how they'll be asked, similarly. Go ahead with your question.
That was my question. I was going to ask if it's arranged in that order, like from how we started from the beginning all the way to the end with the reconstitution, if that's like literally the order of how the test.
My guess is no. My guess is that they probably will reorder it, and it may go in a progressive format, meaning you'll go from like how the beginning started with conversions, then going to the fluid intake calculation. Then they might do the oral based meds like tablets and capsules, and then the oral based meds solutions, then doing the injectables, then the reconstitutions involved with that. So it just depends. I don't know the order. The order's probably going to be randomized. But usually, at least at Allegheny campus, like the first 5 questions or so are always going to be that kind of like standard. Can you convert grams to milligrams, milligrams to grams, and the such. So
Okay, thank you.
you're welcome. Go ahead with your question.
I just have one last question. So like, do you know if we would have any questions regarding like the dosages by weight, where it would be like we've had on ATI, where we would have to do weight conversions, and then it would be like per 12 hours or like 24 hours or something like that? Will we have those type of questions on there, or is it just going to be regular weight calculations?
So I think what you're asking me is like if they're going to say you're going to administer like 4 milligrams per kilogram body weight, patient weighs 127 pounds.
Yes,
Yeah,
those type of questions, and then you would have to, and then like divide by 3 or 2 or something like that.
Oh, okay. If it, yeah. So as far as I know, no. And I don't even know that you get asked. Well, you'll get asked questions like calculate based off of the patient's body weight, but not necessarily like dividing by 2 or dividing by 3. I've only ever seen that on the ATI. But and then on this test, I don't believe you have any weight-based medicine calculations. They just want you to be able to convert pounds to kilograms, or it might be in reverse, but I would say the most likely scenario is pounds to kilograms.
Okay, thank you.
You're welcome. So I will have this posted for you guys on YouTube later tonight, if not tonight, tomorrow. And then you can review it at your, and remember the newer videos are going to be posted towards the bottom of the Boyce 110 playlist if you're looking for it. And then I always tell people, if you are like, if you're subscribed, or if you get like notifications, it'll tell you when I post things, if that's important to you. Otherwise, just check it. Like I said, it'll be up by tomorrow. All right. Well, I know you guys have your test next week. I always tell students, worst case scenario